Scientific notation. Right here, we see something written in scientific notation. So there's always one digit, only one digit, and then a decimal place, and then however many number of digits. It could be 1091543, could just be 1. So what's important is there's one value in the ones position, then a decimal, and then could be something after it that's long or short. Times, and then we have a power of 10. Okay, so the base is 10, and then some exponent, could be negative or positive. So this is scientific notation. And the reason we do this is because sometimes, especially when we're doing some kind of scientific exploration, maybe we're going out into space and we want to talk about super, super huge distances, or maybe we're talking about biology and zooming in with a microscope and we have really, really, really small distances, then we don't want to write out, for instance, I don't want to write the number 0.00000000231 because it's a lot of zeros and it's hard to read exactly what that is. It's a lot easier for me to see what that is if it's 2.31 times 10 to the power of negative 8. Okay, that's a lot easier to write. It's a lot easier to read. Okay, so scientific notation is just a way of taking really large or really small numbers and then rewriting them. And of course, let's look at how we can do that. So this was a really small one. Let's take a really big one. So let's say we have 238,034,000. Actually, that's fine. Okay, and we want to rewrite this in scientific notation. Okay, so as I said before, there's going to be one digit, then a decimal place, and then however many other digits afterwards. Okay, so for us, that means the decimal place is going to go right there. Okay, so we're going to write 2 point, and then however many digits are after that, excluding the zeros that are not inside of other numbers. Okay, see, this 0 is between 8 and 3, so I have to include it. But these zeros are outside, right? See, these zeros here, they're all outside. I don't include them. I don't include these. So 2.38034, okay, times, and then I need to have a power of 10, and there's going to be an exponent here, and the exponent is going to tell me how large this number is. Okay, so to do that, I need to figure out how many zeros come after this position. So there are 1, 2, 3, 4, 5, 6, 7, 8 positions, right? I need to take the decimal place from here and then move it all the way to here. So this is times 10 to the power of 8. Right? And so 2.38034 times 10 to the power of 8 is this number right here. 2.38034 times 10 to the power of 8. Okay, now you can do this on your calculator. It might be, the button might say EE, or it might say exponent, or it might say times 10 to the power of, and obviously we can work things out that way. But let's look at how we can compare these values. So let's say I have 2.3 times 10 to the power of negative 2, and then let's say I have 9.4 times 10 to the power of negative 8, and I want to decide which one of these values is larger. Okay, so because they're in scientific notation, I just really need to look at what's happening here. All right, this number is a lot closer to 0 than this number. This number is larger than this number, right? Because this is 10 to the power of negative 2, this is 10 to the power of negative 8, right? This number is larger than this number, which means that 2.3 times 10 to the negative 2 must be greater than 9.4 times 10 to the power of negative 8. And comparing numbers in scientific notation with positive integers, that's even easier. So 9.2 times 10 to the power of 5. And then we want to decide, well, is that larger or smaller than, let's say, 7.3 times 10 to the power of 4, right? Which one of these is bigger? Well, we can just look at the exponent, right? 5 is bigger than 4, so this number is greater than that number. All right? Now, if you're given a number, it's not in scientific notation, but it's multiplied times a power of 10, we can turn it into scientific notation, or we can change it into scientific notation. So this is what I mean. Let's say we have 0.046. We work this out, and then that's times 10 to the power of 5. And we want to take this number, and we want to put it into scientific notation. Okay, well, we can do that because first we'll just take 0.046, convert it into scientific notation, and then multiply it by 10 to the power of 5. So we want to have one digit and then a decimal place and then however many digits after. Okay, so in our case, the one digit is 4, and we're going to do 4.6. So now we need to make 4.6 equal to this one here. Well, what have we done? The digit, okay, from 4.6 moves over 2 positions. 2 positions. So that means we need to make it smaller by 2. So we multiply by 10 to the power of negative 2, right? We take the decimal from here, 1, 2 spots. This number is the same as that number. And that number we can multiply by 10 to the power of 5. So this works because now we have 2 bases here. They're both 10, 2 powers with both base 10. So we can simply use our exponent rules. And since we're multiplying them, we can add the exponents. So this is equal to 4.6 times 10 to the power of, and now I'm going to add the exponents. So negative 2 plus 5, right? And negative 2 plus 5 is 3. So first we take this and we turn it into scientific notation. Then we multiply it by this value. When we do that, they have the same base, so we can work out the exponent, and here we have 4.6 times 10 to the power of 3. And this is obviously much nicer way to look at the value than looking at it this way, which is expanded and not as easy to see exactly what it is. Here we can just see, oh, well, this is 4,600.